Okay, for the second question, okay, do you have a question? Do you have an answer for this one? So, no, if not, then we know that if that this one is equal with this one, right? We can just switch the cross and the dot. So, one just become this dot v and sorry, o v. So we know that this is just like the question. So this one is equal to is same for from the question from the identity of factor and the p part. For the cross product, if you get this one factor y factor v, if you cross product it and it will produce this factor y factor k. If v cross v is equal k, then v cross w is equal to minus k, right? This one is minus k. So we can just switch, manipulate this formula, became u dot v cross w with minus, and we can get this one is just minus u dot v cross w, and this one just the original one. So the answer is minus 2. Yeah. Okay. Have any question about number 2A and B? Okay, so let's just move on to number C. So C is v dot u cross w. So this one we can just manipulate, switch the formula first, the product and cross product. So v cross u dot w, and can just switch it again with minus. So u cross v dot w, yeah, and this, wait, and this one just the original version again, right, from this one A, and you can just switch it again with minus u dot v cross w, and this one became 2. This one is similar with the original one, and you can get, oh sorry, minus 2 here. Okay, and the last one, D, u cross v cross dot v. Okay, we can just change it again with the cross product and the product, and u dot v cross v. Then if this one is u, so it's v cross v. So for the cross product, the result for cross product is equal to 0 if the factor is parallel, right? So v and v is parallel, right? Because it's the same factor. So the answer for this one is equal to 0. So it's just u times 0, and the answer is 0. Okay, have any question about this one? If not, then we can just move on to the third question. Maybe you can try it first. I'll give you 10 minutes for that one. Okay, does anyone have the answer for this one? Pipe area, pipe volume. No? Okay, let's just discuss it. So, first of all, we need to find the factor AP, AC, and AT, right? So it's just point A minus, point B minus A, C minus A, and T minus A. So this one is 1, 3, and minus 1, and is minus 2, 1, and 3, minus 1, 3, and 4. Okay, this is our factor. So we know that if we have the parallel pipe volume, the formula for that one is the absolute of a AP dot AC cross AP, right? So first of all, we can just cross the AC and AD. So I G K minus 1 to 1 minus 1 I minus minus 1 G plus plus 5. Okay, and then we can just cross it with the AP. So 1 3 minus 1 minus 8 minus 1. So minus 8 minus 3. Wait, actually, this one is minus 5. Sorry, minus 5, and this one is plus 5. Don't forget the absolute. Sorry. Yeah. And can get minus 6 absolute. So the volume for this parallel pipe is just 6 cubic unit. Yeah, 6. That's correct. Okay, let's move on to the parametric equation for the line. Oh, sorry. You have no question for this one, right? Number 15. So this one we only get 2 point, number 15. So point A, 4 minus 1, 2, 1, 1, and 5. So first we have to find the direction factor, or yeah, the direction factor for this equation. So we can just use uh, sorry, b minus a, or factor AP is equal to minus 3, minus 3, 2, and 3. Okay. and we can just use the any point for that parametric equation. So x is equal to, let's use the first one, point A, 4 minus 3t, this one from the direction vector. Number 2 minus 1 plus 2t, and c is equal to 2 plus 3t. This one is from the direction vector. Okay. Have any question about this one? Okay, let's move to number 16. Okay, that's correct. Difficulty, thank you. So first of all, we can get this. This is the symmetric equation, right? And they say that this line is a parallel with the given line here. So we can get the direction vector for this equation, which is 3, 2, and 1, the one below here. And we can use this direction vector to create a new line that pass this point. So we can just keep this 1 plus 3t and 2t because this one is 0, and minus 1 plus t. Okay, let's move to number 17. Okay, for number 17. So we know that the line will be perpendicular with this plane, right? So you get the plane and you should get the normal factor that's perpendicular to this one. And what's the normal factor for this uh, equation? The normal factor is the first or the constant for each variable. So the normal factor is 2 minus 1 and 5. Why? Because from the plane equation, you know that this is a x minus x 0, b y minus y 0, c c minus c 0 equal to 0. So the constant for the each variable is the normal factor here. So we can just use the normal factor and create the equation. So minus 2 plus 2t, 2 minus 3 and 4 plus 5t. Okay, any question for this one? So let's move on to number 18 to 20 from the equation of it. Okay, for number 18, if you have two plane here, that's parallel, then we'll have the same normal factor for both of them, right? So this one is same direction. So we can just use the direction or the normal factor from the first plane, which is x plus 4y minus 3c equal to 1. So the normal factor is 1, 4, and minus 3. And pass through point 2, 1, 0. So we can get the equation of 1 x minus 2 plus 4 y minus 1, sorry, minus 3 c minus 0 equal to 0. Or we can just simplify it by x plus 4y minus 3c is equal to 2 plus. So we get the equation is x plus 4y minus 3c equal to 6. Okay, have any question about this one? No, then we can just move to the next question, number 19. Okay, for number 19, we can get 3 points here. For example, this one. So if we can get the two factor here and crossing each other, we can get a normal factor of the direction for this one. So we can just use any factor that you want, but on the same point here. So we can just use factor A, which is B minus A, and factor, sorry, Let's just use t here, te, and we can just use c minus a. Yeah. So the point is a. Yeah. So the factor is this one is just 1, 1, and 1, and the other one is 3, 4, and 0. Okay, and we can just cross these two factors to get the normal factor for our plane. So CK 3.0. This one is minus 4i plus 3. So plus 3g and plus k. Okay, so the normal factor is minus 4, 3, and 1. And we can just use the same equation for the plane. Minus plus 2 plus 3. Can we simplify the equation? C equal to minus 6. Okay. Minus 14. So. Okay, have any question about this one? This is our equation for the plane. Okay, if there's no question, then let's move on to number 20. Okay, for number 20, we get our plane here, and we get a line here, right? This is the line. Sorry. And this is the point here. So first of all, we need to check if our point is in the line or outside of the line. So we can check it by using the first one. So if x is equal to 1 and is equal to 2t, and the t is equal to half, right? And y is equal to 2.5, which is not our point here. So we can assume that our point here is outside of our line here. So from this line, we can get our first factor, right? This one has the direction factor of just 2, -1, and 3 from this one. And we can just use another point in the line and use that to get another factor. So for example, if we can get the t is equal to 0, then we can get x is equal to 0, y equal 3, and c is equal to 1. Okay, and we can just produce a new factor, just factor a p maybe, and we can just use this factor from 0 to use this point with our initial point, which is 1, 2, and -2. So 0 minus 1 or 3 minus 2, comma 1 minus 2, and get the factor of -1, -1, and 1. Yeah, so 3. Yeah. Okay, and now we get the two factor here, this one and this one. We can cross these two factor to get the normal for our plane. So okay, 2 -1 and 3, then -1, 1, 3. And that our normal factor is -1 and -6i, -9g, and plus k here. So the factor is -6, -1, and 1. This is our normal factor. Then for our equation, we can just use that 6x minus our first point, -1, -9, y -2, plus c plus 2 equal to 0. Or we can simplify this equation with -6x minus 9y plus c is equal to 26. Okay, have any question for this one? If there's no question, then that's all for today. Okay, thank you.